In this module, we will look briefly into how to translate English sentences into logical expressions. I would highly encourage you to read this part from the book as well. There are a lot of examples in the book that I won't be going through over here. In some sense, this part is very easy. In some sense, it is very difficult. What do I mean by easy? I mean that generally when we write a sentence, if it is written properly, you would be able to convert it fairly easily into a logical expression. But as you can imagine, you can have English sentences that are ambiguous, in which case finding the corresponding logical expression would be difficult, because you will first need to understand what is it that you are trying to say. But we'll look at a few examples here. Let's say we have a statement that says some student in CSE 260 have visited Mexico. So let's look at some keywords here. We have some, that means this suggests that we will be using some sort of a there exists quantifier. We will have to have some sort of a predicate that says visited Mexico. We'll have to refer to somehow CSE 260, etc. So first thing we have to do is we have to define what the universe of discourse is. So we can say that the universe of discourse in this case is CSE 260 students. If we do that, then essentially what I have, some student in my universe of discourse has visited Mexico. So let me introduce a predicate called m of x that says x has visited Mexico. And now the answer is going to be there exists x. Oh, by the way, x comes from my universe of discourse, which is from CSE 260 students. And oh, by the way, it has the property m of x, which says that x has visited Mexico. So let's look at another example. Every student in CSE 260 has either visited Canada or Mexico. So again, we have the same sort of situation. We need to decide what the universe of discourse is. Again, let's decide it to be CSE 260 students. Let m of x denote the predicate that x has visited Mexico. C of x denote that x has visited Canada. We have an or. That means that we should be using a disjunction. And the answer will be, so here I have every student, so I have for all x, and in here I have c of x or m of x, because the student has either visited Canada or Mexico. Let's consider this predicate. P of x denotes that x is a prime number. Q of xy says x is evenly divisible by y. Using these predicates, we want to symbolize the following proposition. For sake of discussion, let's assume that the universe of discourse is a set of all positive integers. There exists an odd number which is not a prime. Okay, so first let's see what we want. I want the number to be odd, and essentially that means 2 doesn't divide it, and we want to also say that it is not a prime. So let's look at the answer. We have there exists a number, so we have there exists some x. Now what do we want? We want this number to be odd. By odd, we mean that 2 is not a factor. So q of x comma 2 means x is evenly divisible by 2. That means that x is even. We are negating that. That will give us that x is odd. We want x to be not a prime. P of x says that it is a prime. We wanted it not to be a prime, so we have a negation in front of it. What I want you to be able to do with this is understand that how we are converting these English sentences into the corresponding uh, formulae, and look through the textbook to see some more examples of this and try to see if you can convert those into the corresponding uh, logical expressions. Let's look at one more example. Let's say p of x says x is a prime number. We want to say every integer which is evenly divisible by 10 is also evenly divisible by 5 and 2. I have this requirement for every integer, so I have for all x. What I want is if it is divisible by 10, that says q of x comma 10, then this implies that q of x comma 5 and q of x comma 2.
Once again, we have reached the check before you proceed slide. What I want you to get from this module is if you have an English sentence, how do you decide which variables to choose, which proposition functions to choose, what the universal discourse of the variable should be, etc. Note that this is not unique, but that's okay. The formula that you will come up with would have the same meaning as long as the original sentence you started with is unambiguous. There is no review quiz for this module. Uh, we'll just proceed to the next module from here.